All right, welcome to Unit 2, Lesson 10. We are going to be going over adding and subtracting rational expressions. Remember, rational just means fraction, so don't freak out. Okay, so let's just jump right into this and start with our first example and list what steps do we need to take to add and subtract fractions. Well, first thing, and this one everybody always gets, you need common denominators. Okay, I'm going to make that an expression. Yeah, exclamation point. I'm tired. But we're going to get through this, kids. You need a common denominator. Okay, you absolutely need a common denominator. All right. Number two, well, actually, one can have an extra. You might have to multiply to get common factors. Or common denominators, okay? And just as a quick review, when you multiply the bottom of a fraction, you have to multiply the top by the same thing, okay? After that, all you do is you either add or subtract your tops. And again, the tops, we lovingly call in math numerators, okay? The bottoms are the denominators. And speaking of the bottom, number three, the bottoms, which we call denominators, they stay the same. That stays the same. Okay, we don't change that. And that's going to kind of work into what we're going to do when we get into variables and all that jazz. So, let's move this over here. Okay, here are our steps here just in general. Just a quick review here. So I have 8 and 10 as my denominators. A common multiple, the lowest common multiple, is 40. Okay, you can make it 80, but if you don't use the lowest common multiple, chances are you're going to have to reduce. Okay, there's such a greater chance that you will have to do more work after you're done. So I'm going to use 40. Okay, I can multiply 8 times 5, and what I do to the bottom, I have to do to the top. Okay, so I have 5 over 40 plus, because it's a plus sign, I can make my 10 into 40 by multiplying that by 4. What I do to the bottom, I do to the top. And that's 12 over 40. Now, what do? I just combine my tops. 5 and 12 is 17. And the bottoms, well, that doesn't change. Okay, so that's a quick review of something you probably should have learned in 5th, 6th grade. I'm not sure when they teach it, but I know it is way before 10th, 11th, or 12th grade. All right? Okay, let's find the sum and difference of each of the following rational expressions in simplest form. And state any restrictions on the variables. We kind of go into that next lesson, but we'll talk a little bit about that now. When it comes to restrictions on our variables, please remember the denominator can never be 0. Because if it is, yep, look at that. My board just had a seizure. Oh, God. That will make my fraction undefined, okay? So my denominator can't be 0. So as I look at number 1, G can never be 0. Because if I put a 0 in for that G, 8 times 0 is 0, and the bottom is 0. Same thing with this G right here, okay? So right now I know G cannot be 0 because that would make my denominator 0, and that's a no-no. So I look at number 1. I have a 4G and I have an 8G. And the way I like to do this for this case is I like to look at all the factors in my denominator. I have a G and I have a G, so that's good. What doesn't match is I have an 8 and I have a 4. They both have a G in them. That's fine, okay? But it would be real good if the bottoms were both a common number. And I can make a 4 into an 8 easy by multiplying it times 2. What I do to the bottom of a fraction, you have to do to the top. So I have 6 over 8G, okay? And then, which is nice, I'm still adding, this already is 8G in the bottom. I don't have to do anything to it. I'll leave that at 5. So that's 11 over 8g. Okay, I'm not solving for g. Okay, so this really here, this restriction, I don't have to worry about it right now. When I solve for g, when these become equations, notice there are no equal signs. There's no equal sign, okay? There's no equal sign. We're not solving for the variable. We're just combining these. We're adding these expressions together, okay? So when we have to solve, that's when we really got to pay attention to the restrictions. So I'm not going to say anything about any restrictions anymore for the rest of these until we get into the next lesson where we solve equations and we have to actually find the variable. All right? So here we go. I have a y squared and a y here. In order for them to both have y squared, I would have to multiply my left denominator by y, okay? Because y times y would give me y squared. That takes care of my variable, all right? I have a 3 here and a 4 here. Well, I know the lowest common multiple between 3 and 4 is actually 12. So I have to multiply my left denominator by 3 and my right denominator by 4. Keep in mind, what we do to the bottom, we have to do to the top. So let's look at my right fraction. If I'm multiplying the bottom by 4, I multiply the top by 4. Let's look at the left fraction. If I multiply the bottom by 3y, I have to multiply the top by 3y as well. All right, and let's combine these things. These two give me 21y over 12y squared. This is a minus sign, okay? Now we have 16 over 12y squared. Perfect. I cannot combine, okay? I cannot make one term when something is a variable and something does not. They are not like terms, so I'll just write them like that. I will say 21y minus 16 all over 12y squared. Now keep in mind, that is good. If there was a short answer, that's fine. But as I always say, if this were multiple choice on a test, they might write this in correct order or in standard form. The number without the variable should come first. That means, no, I don't even know what the heck just happened there. I'm just trying to, there you go. This is a negative 16, so I'll put that first. This is a positive 21y all over 12y squared. Okay, so it might be written like this if we're multiple choice on a test. Just know that those two are the same. All right, let's keep on trucking. Okay, that's good. On to the next one. We have a nice little butterfly here. I like them. I love them so much. Boom, look at that, how they bounce on the board. I love that. Now, this butterfly here is for a reason. Whenever you have one fraction, plus or minus another one, but when it's simple like this, you have x over x plus 3 minus 2 over x, okay? You can do something which we like to call the butterfly effect. Okay, I like to call this the butterfly effect. Yeah, I'll be okay. Jeez, I told you I'm tired. I can't spell. I'm thinking A because I'm like, I don't know, should that be an A? But no, that would be an action, a butterfly effect. Well, we're about to do action, but we're actually naming something, so I'm going to leave it as an E because effect with an E is a noun. Yeah, and that's a title, so this is a butterfly effect. Okay, so this is how it works. Excuse my English. I multiply the top left times the bottom right. X times x, and I'll try and match these, gives me x squared. Now, I multiply the top right, okay, by the bottom left. You see I'm making these look like butterfly wings, if you will. And that is, okay, don't forget my sign is minus, right? So it's minus 2 times x plus 3. But it's a fraction, right? That is all over. Now I multiply the bottoms. X plus 3 times x. And that will go in the bottom here. X plus 3 times x. Okay? And if you do your little antenna, yay. So it's just, it looks like a butterfly, kind of like an Andy Warhol butterfly. Okay? So this is what we got. Let's just clean this up. Now I have x squared minus, I'm going to distribute this, 2x minus, man, I'm tired, minus 2x minus 6, because don't forget the negative sign distributes, okay, all over, and if I distribute this, I get x squared plus 3, and my friends, that is great, okay, that's called the butterfly effect. Remember how it starts, okay, that way first, you keep your sign, multiply this way next, all over this, multiplying the bottoms, okay? And that actually looks more like a butterfly when you curve it like that. Okay, so that's a butterfly. I would not do that for number 4. How come? Because in order to multiply this times this, I'm going to have to FOIL, and it would get nasty. Okay, something like this, I would try and get common factors. If it's simple like number 3, I would definitely do it. But for number 4, I'm going to look at this, and I'm going to look at my denominators, and I'm going to try and get them the same. And the first thing you should do whenever you're trying to get denominators the same is identify all the factors. Meaning, I have x minus 1. That's good. What about this? What are the factors here? I can factor out an x, and what gives me left there is x minus 1. It's the same thing. So if I look at this, this is really, I already have an x minus 1 in both. What I'm missing on the left denominator that I have on the right is an x. So I'm just going to multiply this times x. What I do to the bottom, I have to do to the top. So let's evaluate this, okay? I'm going to multiply x times x plus 1. Don't forget, that should be distributed. X squared plus 1x, okay? All over x times x minus 1 plus a negative 2. Now, I could have said minus 2. That's fine. Over x times x minus 1. Now, all I'm going to do is I'm going to combine these. X squared plus x, okay, minus 2, all over x times x minus 1. Now, am I done? They want these simplified completely. The top can actually be factored. That is 2 numbers that multiply to be negative 2. Okay, this should be a positive times a negative. That add to positive 1. Positive 2 and minus 1. And look what they did to us. Tried to sneak one by us. Now, what can I cancel on the top and bottom? X minus 1 cancels with x minus 1. So when everything is all said and done, x plus 2 over x. Woo! It's a little bit of work. But it's simple work. It's simple algebra. I keep on saying this. You need to be good at factoring. It's involved in everything, okay? If you're good at factoring, I mean, the rest is just adding and subtracting. All right, let's take a look at number 5. I'm going to factorize my bottoms here. I'm going to make these all factors. X minus 1 is already a factor. Let's use purple. Why not? That's a nice color. So what are 2 things that multiply to be positive 2? Let me give myself a little bit more room here. Oh, sad. They multiply to be positive 2, but add to be negative 3. So if I get a positive product, okay, I need to either multiply a positive times a positive or a negative times a negative. I'm going to go negative times a negative because they should add to negative 3, and that's 2 times 1. Now, they both have an x minus 1 here. Look how much easier this becomes. Okay, the only thing that's missing in the left bottom or denominator is my x minus 2. So I'm just going to put x minus 2. I'm going to multiply the bottom and the top by x minus 2. And let's see what happens from there. Okay? Distribute this. X squared minus 2x over x minus 2, x minus 1. Plus, okay, 2x minus 1 over x minus 2, x minus 1. Let's clean up the top just a wee bit. Okay, I have x squared minus 2x, okay, plus 2x minus 1 over x minus 2, x minus 1. Okay, the only thing that I know that cancels in the top, if I combine these, my negative 2x and positive 2x cancel, which leaves me x squared minus 1 on top. Okay, but doesn't x squared minus 1 factor? I hate having to write this all the time, but I'm doing it. I'm doing it for you guys. Okay, so the top actually factored. That is a difference of perfect squares. So my top is x plus 1 times x minus 1. That's what that factors out to be. Over x minus 2, x minus 1. Again, they try to trip us up at the end. These cancel. And my answer is x plus 1 over x minus 2. Whew. It's just a lot of rewriting. Like, look at how many times, and let me make you feel a little bit better about this. Look how many times I had to rewrite the denominator, okay? First, I established it. Nothing changed from the bottom. I wrote them again. Nothing changed from the bottom. I wrote it again. Nothing changed from the bottom. I wrote them again. Then I had to write them one last time to cancel. So I literally rewrote 1, 2, 3, 4, 5, 6, 7 times to write the denominator. I could have just combined the tops, but then you guys might have been confused and said, oh man, where'd the bottom go? What happened to the bottom? Okay, so literally half this writing is just rewriting the bottom, okay? So don't feel overwhelmed. It just seems like there's a lot of work on the board, but there really isn't that much, okay? Let's do number 6. Holy smokes. I'm going to factorize my bottom, okay? I'm going to make the bottom so that they're in factored form so I can see if anything matches, okay? I think we're seeing a common theme here. The bottom left, I can factor out an x. What would be left? X minus 2. That's my new bottom. Okay. What about the right side? Well, I can factor out a 2, and I have an x minus 2. Okay, highlighter time. Bang. I see that I have an x minus 2. Wow, that's nice. And an x minus 2. Well, that's just ugly. That's just ugly. Okay, so what am I missing? Well, the right side has a 2, so I should really put a 2 here. Okay, and that's what I'm going to do. So I got to multiply this times 2, which means I got to multiply the top times 2. All right. Now let's look at the green. Let's see what that highlighter looks like. The left side has an x. So let's just put an x here so that it matches, okay? X. So what I do to the bottom, I have to do to the top. Keep in mind, I'm only multiplying this fraction by an x. That's why I'm multiplying this by an x. The left fraction, I'm only adding a multiplication. I'm only, like, you know, I hate to say the word adding, but I'm only having to multiply the bottom by 2. So that's why I'm only multiplying the top by 2. But look at my bottoms. 2x, x minus 2. 2x, x minus 2. And you can see it so much clearly when you factor the bottom. So what I need to do with the tops now is I need to distribute. Bang, bang. I've got 2x plus 4 minus, oh my goodness, that minus applies to everything. So after I distribute my x, I also have to distribute the negative sign. So x times x is x squared. X times 2 is 2x. I also have to distribute the negative sign, okay? So I'm not going to rewrite my bottom yet. I'm just going to distribute the negative sign. So now I have 2x plus 4 minus x squared minus 2x. Whew. All over. 2 times x minus 2, okay? Remember, when I combine these, the bottom stays the same, okay? The bottom stays the same. I don't got to write it a million times twice because I've combined this into one fraction now, all right? So what can I combine or simplify in the top? Negative 2x, positive 2x. I now have 4 minus x squared all over 2x times x minus 2. Okay, yes, I can write those without parentheses. It's multiplication. The x minus 2 has a plus or minus in between it, so I still need to leave that in its own parenthesis. Again, factoring is so huge. difference of perfect squares on top. It's a 2 minus x and a 2 plus x, all right? Which means, what can I cancel in top and bottom? The x minus 2 and the 2 minus x cancel, and it leaves a negative 1, okay? Whenever my items are flipped around a minus sign, it can cancel but leave a negative 1. So what do I have? I have a negative 1 times 2 plus x all over 2x. Okay, that's fine like that. You might see it several different ways if this was multiple choice. Okay, if it was multiple choice, you might see the minus out front, the minus 1, then 2 plus x all over 2x. Maybe they distribute the negative 1 in here. Negative 2 minus x over 2x. No, I cannot cancel those 2's. The 2 on top has a plus or minus connected to it. The 2 on the bottom does not. If it has a plus or minus connected to it, it has to match exactly, okay? It can be written one of any different way, one of many different ways we have written here. But, I mean, that's really it. So we're done with this. There are 3 problems for homework, and I'm going to tell you something on the homework. They are Regents practice. These are problems that came right off the Regents. Okay, just 3 of them. So I want you guys to do 3 of them because we're going to go over these in class, and if you're not in my class, well, look up the answers, I guess. I don't know what to tell you. All right. I bid you adieu. We have one more lesson for this unit before the unit exam. We are not doing my Unit 2, Lesson 11. Our next unit will be Unit 2, Lesson 12. Then we'll have test review, then the test. All right. See ya. Have a good one.